Hi, today topic is loss function. What is loss function? The definition of loss functions, the difference between the predicted values and the actual target values in a machine learning model. The goal of loss function is to minimize the error during the training process to improve the model accuracy. It is a method of evaluating how well your algorithm model or your architecture on your data set. In loss function, this is input, this is the process of training. We got predicted output. This is a true output, actual output. This is predicted output. The difference between predicted output and actual output is known as loss function. There are two types of loss function. The first one is regression loss function. In regression loss functions are critical components used to evaluate how a model predictions match the actual data. For regression task, where the model where the goal is predicted a continuous value. Several loss functions are used in regression loss functions like a mean absolute error, mean squared error, Huber loss, and log cos h loss. These are all regression loss functions, and the each has its own characters and it's suitable for different scenarios in a regression loss function. The first one is mean squared error. What is mean squared error? It is evaluates the average of the square difference between the predicted and actual values. The formula of mean squared error equals to 1 by n summation I equals to 1 to n yi minus yi cap whole square. N means number of samples in a data set. Yi means target values. Yi cap means predicted values. For example, we find out the predicted A, predicted B. 0 and 1 are actual values. 0.2 and 8 are predicted values. Mean squared error formula is 1 by n summation I equals to 1 to n yi minus yi cap whole square. These values are substituted in this formula. These are 0. Y means target value. Target value means 0. 0 minus 0 point whole square equals to minus 0 point whole square equals to 0 0.04. And the predicted B equals to 1 minus 8 whole square equals to minus 7 whole square equals to 40. This is the examples of mean squared error. And the derivative of mean squared error mean squared error by dou y cap dou yi cap dou I. This is the derivative of mean squared error, and the next one is mean absolute error. Calculate the average absolute value between the predicted and the actual values. In mean absolute error, it converted the negative values into positive value. In mean absolute error, mean is taken to make the less function independent of number of data points in the training data set. But the advantages of mean absolute error is the robust of outliers. The formula of mean absolute error equals to 1 by n summation I equals to 1 to n y mod of yi minus yi cap, and the derivative of mean absolute error equals to minus 1 if yi cap greater than yi. 1 if yi cap less than yi. 0 if yi cap equals to yi. This is the derivative of the mean absolute error. The Huber loss means the combine of mean squared error and absolute error. The combination of mean squared error and mean absolute error. And it takes the good properties of both loss functions. The formula of Huber loss 1 by 2 into yi minus yi cap whole square for mod of yi minus yi cap is then or equals to del. Here del into mod of yi minus yi cap minus 1 by 2 del square for 1 mod of yi minus yi cap greater than del. This is Huber loss. And the next one is classification loss function. The second one is the advantages of regression models in mean squared error. Mean squared error advantages is simple to compute and understood. Disadvantages means sensitive to outliers because the errors are squared, which can disproportionately after the loss. And mean absolute error advantages means loss less sensitive to outliers compared to mean squared error, simple to compute and interpret. And disadvantages means not differentiable at 0, which can pose issues for some optimization algorithms. And the Huber loss is the one main advantages in Huber loss means robust to outliers. Disadvantages means require the tuning of the parameters. Like here in Huber loss is del means requires a tuning of the parameter. This is del is a parameter. The next one is classification loss per function. In classification, loss functions are essential for evaluating how well a classification model predicts match the actual class labels. Different loss functions are used in classification loss function. In classification loss functions are including binary, multi-class and imbalanced data sets. Here we discuss the binary cross entropy loss and categorical cross entropy loss. First we discuss the binary cross entropy loss. What is binary cross entropy loss? It is also known as a log loss. It is used for binary classification problems. It measures the performance of classification model whose output is a probability value between 0 and 1. Here, the formula of binary cross entropy loss minus 1 by n summation I equals to 1 to n yi log of yi cap plus 1 minus yi log of 1 minus yi cap. The derivative of binary cross entropy loss. This is the derivative of binary cross entropy loss. And the example of binary cross entropy loss is predicted A, predicted B. Predicted A means actual value is 0.0 and the predicted value is 0.23. And the predicted B means actual value means 1.0 and the predicted value means 0.8. The formula of these values are substituted in this formula after we calculating this loss 0.113. And the next one is loss second. Predicted B means this is the calculation and this is the loss. This is the binary cross entropy loss. The advantages of binary cross entropy loss is suitable for binary classification, differentiable, making it useful for gradient based optimization. Disadvantages means can be sensitive to imbalanced data set. This is all about the binary cross entropy loss. The next one is cross entropy loss or categorical entropy loss. What is cross entropy loss? Means it is used for multi-classifier classification problems. It measures the performance of a classification model whose output is probability distribution over multiple classes. The categorical cross entropy loss formula is H into yi comma yi cap equals to minus of summation I equals to 1 to n summation j equals to 1 to k yij log of yij cap. Here n is the number of data points, k is the number of classes, yj is the binary indicator of 0 and 0 or 1 if class label. J is the correct classification for data point I, and yj is the yij cap is the predicted probability of for class J. Here this is the cross entropy loss derivative. The advantages of categorical cross entropy loss is suitable for multi-class classification, differentiable, and widely used in neural networks. And the disadvantage is not suitable for sparse targets. These are all loss functions.